now is as good a point as any to start. So I guess the learning goals for today are going to be an overview of Android background services, but also we'll go into the Android application lifecycle. I've just lost my screen presenting here.
That might be me. I just started recording on Skype as well.
Okay. Well, I'm recording this, so I can send that around when we're done.
Will it record all the voices as well?
Yeah, it should do. It's recording my mic and my actual line feed, so it should get everything.
Maybe that's awesome. Yeah, okay. All right.
Okay, so learning goals are the Android application lifecycle, an awareness of the actual job scheduler for background services, getting people comfortable with the Android debug bridge, or ADB from this point forward, and just an awareness of how to troubleshoot issues with the services, because often they're easy to start but hard to debug and hard to figure out why they're not working the way you intended. So I guess the best place to start off is with the actual application lifecycle itself with Android. So there's a couple of things to look out for. One being that the Android lifecycle, while it is kind of rigid in the way it works, it's not guaranteed. So if you start the app and it gets backgrounded, it can and will quite often be killed by the system to free up memory. So this is one of the reasons why we use background services, to kind of persist logic and to get around that. Also, there's another reason, if you're doing any sort of long-running logic, you want to keep that off the UI thread, because if you don't, you'll basically crash the app. If the user tries to tap on something while you're running some long-running logic, the system won't respond, and 4 or 5 seconds later it'll crash. So that's basically why we are going to do this talk on Android services. So the best point to start there is with JobScheduler itself. So there's a couple of different ways you can do background services in Android. You can do Alarm Manager, which you can use for if you want something to be really, really accurate, like to the second, but it is not great for battery. And Android or Google themselves actually recommends using JobScheduler. Now the reason for this is JobScheduler, while not being super accurate, you can't guarantee it's going to launch at a particular time. What it's actually doing is it will defer your jobs until some criteria are met, or it will batch them together, so your job will run with a whole bunch of other jobs. In order to reduce the number of wake locks that you keep on the device and to help improve battery life. Because the more times you have to get a wake lock, you're just going to kill your battery in really short order. So I guess that's a good sort of place to start, but I think we should just jump into some code now and actually start looking at how we construct all this. I think the best place to start is probably with the broadcast receiver. So a broadcast receiver, at line 11 you can see broadcast receiver. At line 10 we've actually got intent filters. So this is an intent filter attribute, and basically broadcast receivers listen for a broadcast. It's something that you subscribe to, and you can be notified when a broadcast occurs. Now these can be user-defined broadcasts, but we're listening for system events. So we've got at line 10, we're declaring that we want to listen for boot completed action, user present, battery low, power connected, and power disconnected. Now there's some kind of gotchas here, like action user present actually means unlocking the device. So that might seem obvious now, but the trick is there's actually an action called intent action user unlock, which is pretty confusing because it's actually referring to unlocking or decrypting the file system. So if you use that trying to check for an unlock on the screen, you're not going to get very far. So user present.
A website
Yeah,
Is
to
the
list all
website
those.
definitely listed?
Yep, sure is. I'll actually, after this talk, I'll send around a bunch of links. It's listed on the Android intent page, and there's a whole bunch of actions listed there, and you want to search for the broadcast actions. But I'll make sure I get you guys some docos so that you can actually go and do some research after this, because there are a few caveats to using those. One of those caveats actually is, so here we're declaring these using an intent filter attribute. Not all broadcasts can be, you can't subscribe to all broadcasts this way. Some of them have to be context registered. So we're actually listening for a couple of other broadcasts for screen on and screen off. Those have to be context registered. So here in main activity at line 27, we're actually declaring those actions under a new receiver. We're adding each action for screen off at line 29, and line 30 is screen on, and then we register it. So that's sort of one of the little gotchas, because you can actually put these screen off and screen on actions here. If you put them here in the intent filter attribute, it will quite happily accept that, but it won't tell you that it's failed. So yeah, that's a bit of a pain. But as long as you're aware of that, it does actually list those. You know, if an intent or an action has to be context registered, it will tell you that on the intent documentation. So I'll make sure you get a link to that, and you can go through and figure out which ones are which. But for our purposes, this is all set up the way we want it. So we've subscribed to some system broadcasts now. Where does that come in? So if we scroll down, line 79, we can actually see we've overridden the onReceive method, which is part of the broadcast receiver. So when one of those system events is triggered, onReceive gets called, and then we've just got a case for each one. And they're all, with the exception of power disconnected, they're all going straight through this method. So we'll jump into that. This is all pretty straightforward for onReceive. So move through there. And then here's where we get to the meat of the job scheduler, I suppose. This is the actual job scheduler object. Now, job schedulers can't be instantiated directly. You do have to get them through the context object, because they're a system service. So in Android, a lot of things are dependent on context objects. When you're starting an activity, or if you want to get access to basically anything on the device, like the GPS, the camera, the storage, just about anything, you have to get that as a system service. So that's what we're doing here at line 42. Then from there, we're carrying on down to line 45. Job scheduler essentially has, you can check to see all the pending jobs. So when we create a job, we create it with an ID, and that's what we're doing here. We're just checking if that ID exists. If it does exist, then we're just returning. We don't want to create a duplicate. If it doesn't exist, then we're just going to continue on and actually create the job itself. So here, what we're doing is you have to pass in a job info object to the job scheduler. So at line 52, we are going job info.builder, giving it an ID, and then at the end here, this is just long form, and we're basically just giving it the actual job service that we want to kick off once the schedule has been run. We'll get into the job service in a little bit. We'll continue on with the actual building of the job. So there's a couple of different ways you can schedule job scheduler. So you can either do them periodically. So yeah, say every 10 minutes, every 60 minutes, however you want to do that. Basically, if you do that, it's going to try and run every 10 minutes or so, no more than every 10 minutes basically. But there's no guarantees on exactly what time that's going to happen, because it does batch and defer. here, what we've actually done is at line 58, we're just going to set this up to run once when these conditions up here are met. So basically, we've set the minimum latency. So after the job has fired, it will run after 1 minute. And then what you can also do at line 59, you've got the content max delay. So because JobScheduler has a bit of leeway, you can kind of tell it, hey, I don't want you to wait any more than 2 minutes before you actually fire. So you are kind of giving it some restrictions on how long it can wait. Once you've done that and set all that up, actually there's supposed to be another line in here, which I'll add. There's also something which is pretty cool, is job.set persisted. Now, in the old days, the reason why you actually had to use this broadcast receiver was because if you started a service and the system rebooted, services were just killed off and forgotten about. So you actually had to register to listen for a reboot so that you could reschedule your service, which is a pain. You had to essentially write a reboot receiver just to do that. JobScheduler is kind of friendly in that way, and it actually gives us a set persisted flag. So if the system reboots, if you've set this, it'll just reschedule itself. It's really handy in that respect. Okay, so then once you've actually set up your job info object, basically you just pass it to jobscheduler.schedule, and if it's successful, it will pass back true Boolean value, or if it's failed, it's false. So once we've done that, at line 65, we're just passing that result to the logger so that we can actually see what's going on. Now, kind of the meat. Yeah.
That's really cool. A couple pro tips here. On line 58 and 59, just because it's available in IntelliSense doesn't mean it's available in the Android API platform.
Right, yes.
So it's very easy to set a value here that's only compatible with Android 7. And if you run it on Android 5 or a lower emulator or a lower device, the application will crash.
Right.
So you need to check the API docs from Android to make sure that the method you're calling is actually supported.
Yeah, that's a very good point. So provided that you've done that and you know that it's not going to crash and that you're actually supporting the right APIs, I guess the best way now is, and probably the meat of this, is actually debugging an Android service, because it can be difficult to figure out what's going on. So one of the key components of that is the Android Debug Bridge, or ADB. Now, there's a bunch of useful stuff that you can get out of that. So what I might just do is open a new window. There you go, Tools, Android, ADB command prompt. So pull this up. I'm actually going to start the app as well. So that we can get that service running. No, it hasn't actually. It's in shipping, so I know it's on its way at least.
It's got a different courier now?
Same courier. They got through all their problems. Okay.
They couldn't ship anything. So they're trying to use another courier.
Yeah. So okay, we've got the app started, and here is our ADB window. So let's see now. First things first, ADB devices. This gives you a list of, actually I might just give you a quick run through the different commands that are handy to know with ADB. So you've got ADB devices, which is prints a list of all the connected devices. ADB logcat, which shows you the device log. And there's some ways of filtering that as well, because the signal to noise ratio is quite bad. It can be very hard to sort of ascertain what's going on unless you can filter it. ADB push and pull. So yeah, uploading and downloading files from the device can be very handy. And ADB shell, which I seem to have missed. which is just a shell on the local device. And the shell comes in handy because what you can actually do is you can actually fire those broadcasts, some of them manually, so you can actually tell it, oh, fake that the battery is low or something like that. There are some caveats around that. There are some that you cannot send manually because the system won't let you, so it's one to check the documentation on. But again, I'll send you some links after this so that you can inform yourselves and figure all that out. So, back to our device. So ADB devices. Now, ADB devices is good for confirming devices are actually connected, but also if you've got multiple devices connected, which I don't at this point, but this here where it says list of devices, if you copy this starting string, that's the identifier for it. So if there was multiple devices connected, with the -s flag, you can connect to that device and then go logcat. And that gives us a huge amount of data, basically for the last few hours, what's been happening on the phone. So you don't actually need to be connected to see, you know, if a service was running on your phone and then you think, oh, I just want to check that, you can plug into logcat, and as long as it's in the last few hours, you should be able to catch it on the logs. Obviously, there's a lot of noise here though, so what we'll do is kill that. Screen. And then what I'm going to do is I'll go ADB logcat pipe. This is for Windows. You can use grep if you're on Linux or something like that. But we're going to look for the tag that we've set, the logger tag. So mine's called BB locator. And nothing there at the moment. So how can we check? Let's try firing that. And then what we've actually got here, I've got some log comments in on receive. So every time on receive is called, we actually find out what triggered it. So if we go back here, we can actually see we've got the screen on, intent was received, and we scheduled a job. Then the screen was turned off and it basically went through, it checked the ID and it found that there was already one there. So it didn't schedule another one. We don't want that. So once you've got them there, you get into debugging. Now, I am a huge fan of just using logcat for this because using the debugger and using breakpoints, while you can use them, it's a little bit finicky, especially on emulators. If the app disappears from the screen sometimes, or just at weird times, the debug, the Visual Studio debugger will just disconnect. Whereas logcat always stays connected. And actually, we can see in the background while we've been mucking around in here, job 2 has actually started. And then it's finished processing. And any second now, we should actually get, should say update location. Any minute now. It started those jobs. There we go. Finished the job, and then it's passed off our actual task. So now that I guess you can see what's happening on this side of things, we'll go back in and actually take a look at the location service itself. So this is the service that we started, that we handed through to the job scheduler using the job info object. So the important things here are the cancellation tokens, which are pretty much required so that you can actually keep track of of when you've actually completed the job. Because one of the most important things about job service itself is that this is still running on the UI thread. So you still need to hand off the logic to either a background thread or an async task, something like that. And the most important thing is when you're finished, you have to call job finished. If you don't call job finished, it will keep a wake lock and you'll look terrible in the battery stats if you don't just, kill your battery. So you have to make sure you do that. And yeah, the other important thing is that you have to remember that this is still on the UI thread. So here we're actually starting a task and then we're passing it through to device location service, which is where you would actually put your long running logic. And then when you're finished here, you just return with your result, and your service will actually, once it gets its on stop job, it will take care of the cancellation token and return true. So this is another thing that you have to watch out for. True indicates to the job manager whether you would like to reschedule this job, or false to drop the job. So you have to do that, but regardless of the value returned, the job will stop executing. So that's.
I noticed in your job finished online, I can't see anymore.
Yep.
There was a parameter for rescheduling as well.
There is actually, yeah. There's a couple of different ways that you can do that. So yeah, job finished. So needs reschedule. So here, if we say, oh, we're going to finish the job now, you can actually tell it right here if you want to reschedule that or not.
Okay. Then you don't need to override the event.
No. One of the other important things to remember, and it caused a little bit of confusion, is some people take this to mean job finished. Oh, hey, okay, so we've just killed that service now. This is just this job. So if you want to actually go and kill the tasks, the future periodic tasks, you have to go back to your job scheduler and do it there, because this is just taking care of this this instance or this run. So yeah, that's something that catches a lot of people out. I figured it's something important to actually mention. Okay, go back here. I'm going to go to README, make sure we've gone through everything. What I might actually do is just to show you guys what we can do with ADB. So you can go ADB shell. What I'm actually going to do is now I'm going to fire an intent. What I might need to do is go get two of these open. No, I won't need to. The log will still keep running in the background, so we can just refresh that later. Now I'm going to run one of these manual broadcasts. So we'll run the battery low broadcast. Okay. Is it AM broadcast? I say. Type for some reason. Try this again. Okay, come on. It's running a bit slow. It's probably because I'm doing a million things with recording. This shall work.
Trying to paste.
No, I can't. It's just really slow, actually, I think. Just hit backspace 5 times and see if it catches up. Yeah, it's just really slow. Okay. It's usually much more responsive if you're not recording and Skyping and running an emulator at the same time. Yeah, I might leave you guys to play around with that a little bit. You can jump into the shell. You basically see it's like an ordinary sort of Unix shell. And I will actually give you guys these manual triggers and everything that's in this file so you can see what's happening. So I guess that's pretty much the meat of it. Does anyone have any questions, I suppose?
Yeah, well, kind of specific to our issue. our background in job scheduler. What were the problems that we had with ours?
Yes. Okay. So one of them was that that little gotcha with the, where is it? At the top here. The user present. So it was the action user unlocked, which we thought was for a screen unlock, but was for the decryption of the file system. That one was a funny one because that was news to me as well until I actually went and read the docker. I spent about an hour and then I was like, oh my God, we're actually not even asking for the right action. So that was a bit of a funny one. Also, the context registration was one of the other ones. And the third thing I think was just we had to restart the service after a certain, it was the configuration of how we got our GPS location service. We weren't hitting the configure for that at the right point, so it was just throwing an exception. But once we figured that out, it was really just a logic problem. So that was about it really. Any other questions?
Don't think so.
No. All right, cool. Well, I might call it there, I guess, and I'll send around some links. I'll send around a link to the GitHub for all this so that you can actually look through the code yourself, have a bit of a play around, and test out ADD and things like that. If you do have any more questions, feel free to give me a shout and I'll help you out. See if we can, get you guys started.
Sounds good.
That was really good, thanks.
No worries. All right, guys, have a good day.
Good job.